Good afternoon, learners, and welcome to Dr. D. Patil Vidyapith Center for Online Learning. I'm Professor Anand, the course coordinator for Blockchain Technology Management. Learners, in this session, we are going to discuss about the syllabus of OMBB TM 301, that is Basics of Blockchain Technology. So, this is the first course of Blockchain Technology Management, that is Basics of Blockchain Technology. The course code is OMBB TM 301. So since this is the very first session for this semester, so in this session, I'm going to discuss the syllabus of OMBB TM 301. And if time remains, we'll start with the first unit of this course. So let's start with the course description, course objective, and what are the units, what are the chapters of this course, that is OMBB TM 301, that is Basics of Blockchain Technology. So this course, this is the very first introductory course. Like I said, that is Basics of Blockchain Technology. This will gives you the complete information, the basics of blockchain technology. So this course is useful to familiarize yourself with the basic elements of blockchain technology and their importance. So the students, you will be able to understand the importance and you will be able to understand the modern concepts of blockchain technology systematically. So this unit will give you the basics of blockchain technology. What are the basic elements of blockchain technology? What is their importance? What are the modern concepts of blockchain technology? What are the emerging trends? So all the basics that you're going to learn in this very first unit, that is the very first course of blockchain technology as a specialization course. So the objective of this course is to assess the blockchain applications in a structured manner, understand and explore the working of blockchain technology, how blockchain technology works, how it operates, to have a strong technical understanding of blockchain technology, and to know the applications of blockchain technology. What are the current practices of blockchain technology, where it could be used? What are the research activity in which blockchain technology is being involved? So these are some of the objectives of this course, that is OMBB TM 301, that is Basics of Blockchain Technology. So once again, I welcome you all to the third semester of MBA and the specialization course, that is Blockchain Technology. So I'm Professor Anand. I will be dealing with the OMBB TM 301, 302, and 303. So three subjects I'm going to teach you for blockchain technology as a specialization course. So now we'll come to the course outline. We have understood about the course description. We have understood about the course objectives. Now it's time to understand what are the chapters of this course. So the first unit is Introduction to Blockchain. So here in this unit, you will be understand what is blockchain, what is the history of blockchain, how blockchain has been evolved, what is the purpose of blockchain technology, what is the mechanism behind the blockchain technology, and how the network operates, what do you mean by the blockchains, what do you mean by transaction, what are the challenges of blockchain technology, what do you mean by the P2P system? What do you mean by key as identity and digital signatures? So the first unit will give you the basic concepts of blockchain technology, starting with the definition of blockchain technology, the purpose, the history, the mechanism, the network, and the basic elements of blockchain technology, that is the blocks and transactions, the digital signatures, and what are the challenges of blockchain technology. So that is the first unit that we are going to cover. In that, we are going to cover these elements. The second unit is Introduction to Cryptography. Like I said, that cryptography is the technology, cryptography is the concept that works behind the blockchain technology. So we can say that blockchain technology is built on the basis of cryptography. So at the base of blockchain technology is cryptography. So it is essential to learn what do you mean by cryptography, how cryptography works, what are the algorithms of cryptography. So the second unit will give you the complete understanding of cryptography. That is, what is cryptography? What are the types of cryptography? That is public cryptography, private cryptography, and what are the elements of cryptography that we are going to understand in this second unit of this course. The third unit speaks about the blockchain components. What are the components that is made of, that is composed of a blockchain? So the first component could be the cryptographic hash function. You can see the hash value. The second one is the cryptographic nodes. The third one is the transaction. The next one is the asymmetric cryptography, addresses, address derivation, private key storage, ledger, blocks, and chaining blocks. So the third unit will give you the understanding of blockchain components. Now we'll come to the fourth unit, that is consensus models. Consensus models are a critical part of a blockchain network or a blockchain application. Without consensus model, a transaction is not going to be validated. A transaction is not going to be recorded into the blocks. If a transaction has to be recorded into the blocks, then first it should be validated. How it is validated? Through the consensus models. So consensus models plays a very critical role in the operation of blockchain technology. So here in the fourth unit, we are going to understand what are the different consensus models that exist. There are different types of consensus models, like it could be proof of stake, it could be proof of work, it could be proof of elapsed time, it could be round robin. Then we will have the comparison matrix of different consensus models, that is proof of stake, proof of work, proof of elapsed time, and round robin. We are going to compare this. And then we are going to learn about the ledger conflicts and resolutions. That is all from the unit number 4, that is consensus model. Now we come to the unit number 5, that is forking and cryptographic changes and forks. So here, whenever a change is occurred in the blockchain application, in the blockchain network, then it triggers a fork. We call it as a fork. If you make a change in the protocol of the blockchain, it triggers a fork. If a new cryptocurrency is announced, is declared in that particular blockchain network, then it triggers a fork. If a new rule is introduced in the blockchain network, then it triggers a fork. So forking means a change. Forking means a change. So there are different types of forks. It could be soft fork, it could be hard fork. So that we are going to understand in the unit number, that is 5, that is forking and cryptographic changes, that is in the unit number 5. And we're going to understand how it works, how a change is occurred, what are the different types of forks. It could be soft fork, it could be hard fork. What do you mean by soft fork and what do you mean by hard fork? When soft fork is triggered, and when we call a change as a hard fork. So that we will cover in the unit number 5, that is forking and cryptographic changes. Then in the unit number 6, that is Ethereum technology overview. So in that, we are going to have an overview of Ethereum. What is Ethereum? What is the role of Ethereum in the blockchain technology? What do you mean by Ethereum clients? How to manage the accounts in the Ethereum environment? What is Ether? Ether is the native cryptocurrency of Ethereum blockchain platform. Like Bitcoin is the native cryptocurrency of the Bitcoin blockchain network. In the same way, Ether is the native cryptocurrency of the Ethereum blockchain platform. We are going to understand the Ethereum foundation, its architectural overview, how it has been designed, Ethereum blockchain platforms, what are the different Ethereum platforms. We are going to analyze the Ethereum blockchain as well in the unit number 6, that is Ethereum technology overview. Then we'll come to the unit number 7, that is the smart contracts and dApps and DAOs. Smart contracts are the integral part of blockchain technology. Smart contracts are self-executing contracts, and the terms of agreement are being hard-coded into that contract. And whenever the terms are fulfilled, that self-executing contract is automatically executed. We don't need to execute it. That's why it is called as self-executing. Whenever the terms of the agreement of that contracts are realized, are met, are satisfied, then the contracts will get executed automatically. So that is a smart contract. So we are going to learn about the smart contracts, the Ethereum virtual machine, that is the EVM, which will convert the source code into the code that is going to be understood by the compiler. Like a JVM works, in the same way EVM also works in case of the blockchain technology. So we are going to learn about how EVM works. Then we are going to learn about the decentralized autonomous organizations, that we call it as DAOs. And we are having a quick overview of the Remix using JavaScript and VM. So here in this unit, we are going to understand about the smart contracts, about the dApps, that is the decentralized autonomous organizations, and the DAOs. So that is unit number 7. So you can see here the quick overview of Remix. So here we are going to develop the smart contracts by using the Remix environment. And we are going to use the Solidity as the programming language for developing the smart contracts. So we are executing that smart contracts. We are developing the smart contracts, and we are executing it onto the web-based environment, that is Remix. Then we come to the unit number 8, that is Hyperledger. In that, we are going to understand about the Hyperledger. What is Hyperledger? Hyperledger is basically an umbrella of platforms, which is a platform of platform, which provides multiple resources, multiple tools to develop various blockchain applications and various blockchain tools. So we are going to understand about the Hyperledger, its architecture, and the tools which are present in the Hyperledger, or what are the various platforms which are present in the Hyperledger. As the Hyperledger is an umbrella of platforms which contains multiple platforms, which contains multiple tools and resources to develop the blockchain applications. Now we are coming to the unit number 9, that is Solidity programming, where we are going to understand the basics of Solidity programming language. as we are going to use the Solidity programming language to develop the smart contracts, and then we are going to execute it on the web-based environment, that is Remix. So for that, we need to learn about the Solidity programming language, the basics of Solidity programming languages. It's the layout of the Solidity source file. What are the different components of Solidity programming language, of Solidity source file? What is the structure of a contract? What are the different elements of a contract? When you're writing a contract, what elements are compulsory and what elements are optional, that we're going to understand. We are going to understand the variables, the types, the local variable, the global variable, the input parameters, and the output parameters as well. So overall, we are going to learn about the basics of Solidity programming language in unit number 9, so that we could able to develop smart contracts that could be executed on the Remix environment. Then we are coming to the unit number 10. That is, in that we are going to learn about what are the current emerging technologies or trends in blockchain. Say, for example, it could be the cloud-based blockchain. It could be the multi-chain, Geth, Stellar, Ripple, R3 Corda, Blockchain API, and blockchain sandboxes. So these are the emerging technologies of blockchain that we are going to understand in unit number 10. So this is all about the syllabus of OMBBTM 301, that is the basics of blockchain technology. So now let's start with the actual syllabus, actual content of this course. Give me a moment. Let me share the screen. I hope that my screen is visible. I am quite audible. So let's start with the first unit of this course, that is the basics of blockchain technology. And the first unit is Introduction to Blockchain, where we are going to understand about the concept of blockchain, the definition of blockchain, the history of blockchain, the origin of blockchain, how blockchain has been evolved, what are the building blocks of blockchain, and what are the objectives, purpose, what is P2P system, and what do you mean by what are the other elements of blockchain technology. So this is the agenda for this first unit, where we are going to understand about what is blockchain. In that, we are going to understand the history of blockchain, purpose of blockchain, blockchain technology, what is the mechanism of blockchain technology, and what are the networks. And in blockchain origin, we are going to understand about its objectives, the challenges of blockchain technology, and transaction and blocks. And last, we are going to understand about the P2P system, how the P2P system works. So let's begin with the definition of blockchain. What do you mean by blockchain? So blockchain consists of actually two words, a block and a chain. So a blockchain is a chain of blocks, One block is connected to the next block, and the next block is again connected to the next block. So in that way, it creates a chain of blocks. And what every block contains? Every block contains the transaction data, the timestamp, and the hash value, and the actual transaction data. So every block is having 4 elements. The first element is the timestamp, the second element is the hash value, and the third element is the actual transaction and the timestamp. So every block contains these elements. And with the help of the hash value, one block is connected to the other block. So in this way, it creates a chain of blocks. But if you see the definition of blockchain technology, a blockchain is a distributed ledger It's a distributed ledger which allows the peers to transact in a peer-to-peer manner without requiring a third person or a central authority. So basically, it's a decentralized database. Remember, it is a decentralized database. Whenever we heard the concept of database, we comes into the mind it is a centralized. But in case of blockchain, it's a distributed digital ledger, or you can say distributed digital database, but which is decentralized. That database is shared among all the computers of the network, among all the computers of the network, among all the nodes of the network. That is nothing but the miners. Every node, every computer, every miner is having the copy of the database. That is the digital ledger. Everyone is having the digital ledger. And whenever a transaction took place, first it is validated by the miners. If it is found valid, then it is going to be entered, registered, recorded, stored into the blockchain. So once it is stored into the block, that transaction is not edited. Means what? Once a transaction is entered into a block, it is simply impossible to later on modify it, to later on either delete it or modify it or change it. So that's why it's provide a high amount of security to the data once it is entered into the blocks, because the blockchain is immutable. Means once it is recorded, it is simply impossible to make any changes into that block, into that transactions. It is simply impossible because it is immutable. So now we'll go with the definition which has been given in the textbooks. That is, a blockchain is a distributed ledger technology that allows for secure and transparent transactions between the parties without the need for the central authority or any intermediary. So in case of a traditional money transfer, if I want to transfer a money to XYZ, then I should have the bank account. And again, the XYZ should also have the bank account. So here bank is the central authority, is a intermediary who will validate the transaction between me and that XYZ. But in case of blockchain technology, we don't need any bank, we don't need any intermediary, we don't need any central authority. I can directly transfer the digital currency from my account to XYZ's account. So that is how that is the main concept of blockchain technology, that two persons can transact in a peer-to-peer manner, that too in a very transparent way and very in a secure way. So it provides transparency, it provides security to the transactions. So it's a database that is shared among a network of computers where each block in the chain contains, like I said, a timestamp. Timestamp means what? When the transaction is entered into the block, what is the time, what is the date, and a record of specific transaction. That is actually the data of the transaction that pertains to the transaction. And once the block is added to the chain, it cannot be altered or deleted in any way. So making the data on the blockchain immutable, very secure. So this is the main concept of blockchain. So basically a blockchain is a distributed digital ledger that allows for secure and transparent transaction between the parties without requiring any need of intermediary or central authority to control the transaction. That is the main concept of blockchain. Let's move on to the next concept of this session, that is, what is the history of blockchain, how blockchain has been evolved. So the origin of blockchain technology has been traced back in the year 1991, when the two researchers with the names Stuart Haber and W. Scott Stornetta, they have proposed a cryptographically secured chain of blocks to store the documents, to store the information. But however, until the year 2008, so in 2008, the first blockchain has been introduced by the unknown person that we call it as Satoshi Nakamoto. That is in 2008. So the first blockchain, that is Bitcoin, was introduced in the year 2008. And Bitcoin was designed as a centralized digital currency. So the purpose of this Bitcoin is to introduce an alternative digital currency that uses the blockchain technology, of course, to record the transactions and enables the peer-to-peer transactions without requiring the need for central authority or intermediary. And it is very interesting to understand, to know that the first Bitcoin block, known as the Genesis block, was created in the year 2009. That is January 3, 2009. So if you see the history of blockchain technology, it was started with the researchers Stuart Haber and W. Scott Stornetta, who proposed how cryptography can be used to secure the information. But the shape has been given by the Satoshi Nakamoto in 2008 by inventing the first Bitcoin. And in the year 2009, the first blockchain, the first Bitcoin block with the name, that is Genesis block, was created. So in the year 2009. So, but over the years, blockchain technology has evolved and it has been expanded beyond just a digital currency. Nowadays, we will find that there are many applications of blockchain, many application areas of blockchain, like it could be used in supply chain management for the product traceability. It could be used in healthcare. It is used in finance. It is used in banking. It is used in insurance sector for the claim settlement. It could be used for public voting system. It could be used as a digital identity. So nowadays, the blockchain has been expanded. It is not just used as an alternative means of digital currency, but it has been expanded beyond that. And that expansion has started in the year 2014 when Ethereum was introduced. So it was a milestone, a development in the history of blockchain, that is the introduction of Ethereum in 2014. Why? Because the Ethereum has introduced the concept of smart contract. So that has revolutionized the entire blockchain technology, that has revolutionized how the blockchain operates. So here, the smart contracts are self-executing contracts with the terms of agreement between the seller and the buyer being directly written into the lines of code, into that computer program. And this allowed for the development of decentralized applications that we call it as dApps, decentralized applications. Decentralized applications, why they are called as decentralized? Because the application, the smart contracts are executed on multiple devices simultaneously. That's why they are called as decentralized applications, dApps, which runs on the blockchain. So the introduction, the invention of Ethereum was considered as a milestone development in the history of blockchain technology because it has introduced the smart contract and which has revolutionized the entire blockchain technology, how it operates. And in the recent years, various industries, they have started to explore the potentials of blockchain technology, leading to the development of private and public blockchain technologies, blockchain platforms for use in supply chain management, for use in finance, for healthcare, and other industries as well. So today, blockchain technology continues to evolve. Still, it has been evolving, and that day is not far away that we will find blockchain in every application and is being expanded, being explored for new applications as well, such as the decentralized finance that we know as DeFi. That is, again, we could use it as the NFTs, that is non-fungible tokens. NFTs, by using NFTs, we can represent the virtual or non-virtual assets on blockchain platform. Not only that, we could also transact the NFTs on the blockchain platform. We can purchase the NFTs and again, we can sell the NFTs as well. So these are the new application areas of blockchain, such as the decentralized finance and NFTs, that is non-fungible tokens. Now let's understand what is the purpose of blockchain. The purpose of blockchain technology is to provide a decentralized, transparent, secure, and immutable system for recording the transactions and data. So basically, they want to provide a decentralized system which is transparent, which is secure, which is immutable. For what? For recording transactions and data. That is the main purpose of blockchain. And blockchain technology enables the creation of a digital ledger that can be used to record and verify the transactions without the need for the intermediary or the central authority. And one of the key purposes of blockchain technology is to enable secure and transparent transactions between the parties without the need for intermediaries and central authorities. So this is the whole purpose of blockchain technology, that they want to provide a system which is decentralized, which is transparent, which is secure, which is immutable for recording the transactions and for data. And that too without the need for central authority or an intermediary for controlling the transactions. That is the whole and sole purpose of blockchain technology. Now let's understand the mechanism that works behind the blockchain and what are the networks. So there are three pillars on which the entire blockchain technology has been built upon. The first pillar is the cryptography. The second pillar is the distributed consensus models. And the third pillar is the decentralized network that will record and verify the transactions. So these are the three pillars on which the entire blockchain has been built upon. So it is essential to understand these three pillars in a detailed manner. So the first pillar is the cryptography. What is cryptography? Cryptography is an art, or we can say a science of securing the information by using the mathematical algorithms. What this cryptography will do? The cryptography will convert the plain text into ciphertext so that the message could be stored securely, so that the message could be transmitted over the insecure transmission line without the fear of it is being hacked by the unauthorized persons. So cryptography is the main technology which is used for blockchain that provides security for the blockchain. So like I said, that it is a practice of secure communication using the mathematical algorithms to convert the message into an unreadable format that we call it as ciphertext. So there are various algorithms that could be used to convert the plain text into unreadable format into ciphertext. And it is a fundamental component of blockchain technology, which is used to secure and protect the data on the blockchain. So this is the first pillar, that is cryptography. The second pillar is the distributed consensus models. So in order to understand the distributed consensus model, we need to understand the traditional banking system. What happens in case of a traditional banking system? Why we need a bank? Why we need an intermediary for traditional financial transactions? Because the bank is the intermediary who will validate, who will verify the authenticity of the transaction, isn't it? Because if there is no third person is involved in a financial transaction, then there are many chances that a fraud can happen. Now we can see that instead of many safeguards, instead of many protections, there are many frauds are happening. In case of the funds, in case of money stealing. So how to protect it? How to protect the data, the transaction from these hackers? So here we need to implement a kind of mechanism. In case of a traditional banking system, in case of a traditional financial system, a bank will take care of it. But even with the bank, cheats are been occurring, frauds are been occurring. So bank will verify the validity, the legality of the transaction. But in spite of that, there are various cases of cheating and frauds are happening. So here, in case of a blockchain technology, there is no third person is involved. There is no central authority is involved. Now then, who is going to authenticate whether the transaction between these two parties is valid or invalid? Who is going to authenticate? Authentication is required. Is it direct authentication or indirect authentication? In case of a traditional financial system, we are having the direct, we are having the validation by the banks. But in case of a blockchain technology, a validation is being done by the consensus model, by the software. So validation is important. Who is going to do that validation? In case of the normal traditional transaction, banks are doing it. But in case of blockchain, it has been done by the consensus model. Validation is important so that we can check the validity of the transaction, the legality of the transactions. And in case of blockchain, that validity checking is being done by the software that we call it as the consensus models. So to ensure the security and the immutability of the blockchain, there are various consensus model mechanisms are used, such as it could be proof of work, proof of stake, proof of elapsed time, round robin, etc., etc. So in case of proof of stake, we need to, as a miner, has to put the amount of cryptocurrency at a stake in order to get the chance to validate the transaction. Because there are multiple miners. So from multiple miners, who is going to validate the transaction? If I'm implementing proof of stake, so in that case, the miner who puts the maximum amount of stake in the form of digital currencies will be given the first priority in case of proof of stake. And in case of proof of work, the miners has to solve a complex mathematical puzzle. So among all the miners, the first miner who is going to solve the complex mathematical puzzle will be given the first chance to validate the transaction. And upon successful validation of the transaction, the miners will be rewarded with the cryptocurrency. That is how the entire consensus model works. So we are going to learn about these different types of consensus models in very detailed manner as and when it comes in our syllabus. But basically, consensus models plays very, very important role. Consensus model will validate the transaction, whether the transaction is valid or invalid. If it is valid, then it is allowed to be entered into the block. If it is invalid, then it is not allowed to be entered into the block, as simple as that. This is the work of consensus model. So this is the second unit, we can say second pillar of the blockchain mechanism. The first pillar is the cryptography. The second pillar is the consensus model. And the third pillar is the decentralized network that will record and verify the transactions. So basically, it's a network. It's a network of computers. That is the network of nodes. That is decentralized. So the blockchain network consists of this distributed network of computers that we call it as nodes that works together to validate, and it will record the transactions on the blockchain, isn't it? Now, you may ask that when one miner is validated the transaction, he has checked the transaction, then the transaction is to be allowed to be recorded into the block. It's not like that. Even as a miner, I have validated the transaction. It does not mean that the transaction is valid. From my point of view, I have authenticated, I have validated this transaction, and I found it as valid. But it's not only the question of me as a miner. What about the rest of the miners? The rest of the miners, suppose that there are 10 miners and I am the one of the miners. So here I have validated the transaction. So once I validate the transaction, I will broadcast that transaction into the network. And after that, the remaining 9 miners will again check the transaction details. They will again validate the transaction. And if they found, if the majority of the miners found that, yes, whatever I have as a miner validated, authenticated the transaction, it is valid. If they come to this consensus, if they come to the conclusion that yes, it is valid, then only that transaction is actually stored into the block. Otherwise, it is not stored. So this is the mechanism This is the mechanism of how a transaction is being recorded. I will explain in a very detailed manner by taking the example, by taking the case studies of how a transaction is validated, how it has been broadcasted, how it has been actually entered into a block. So that I will explain in a detailed manner by taking the case studies and practical example as well. So these are the three pillars of blockchain technology, that is cryptography, the consensus models, and decentralized network, on which the entire blockchain technology has been built upon. Now, what are the objectives of blockchain technology? To create a decentralized network. That is, there should be no need for central authority to control it, but instead, the system is distributed among a network of computers, and which is making it more secure, reliable, transparent, and resistant to tampering. So the first objective is to have a decentralized network. The second objective could be transparency. That is, it enables the transparent and immutable records. Anybody can read the records into the blockchain, but they cannot make a change. So all records of the blockchain are transparent, meaning that once the data has been added to the blockchain, it cannot be changed or altered or deleted in any way. So this makes it easier to verify the authenticity of the transaction and reduce frauds. So if a transaction is been executed through blockchain, then I would certainly I can see that it is transparent. It is I can rely upon it. The third objective is to provide security. Like I said, that cryptography is the technique which is used to secure the data and the transaction, and that will prevent the unauthorized access. And because of the cryptography, it makes the platform more secure for storing the information, and even we can transfer the sensitive information over the insecure network, that is security. The next objective could be to provide efficiency, improve efficiency, to streamline the processes and reduce the cost by eliminating the intermediaries and even automating some of the processes by using smart contracts. So definitely smart contracts will automate some of the processes, and blockchain will reduce the transaction fees. If there is no third party involved, then definitely there is no transaction fees. So this will make this technology, the transaction, less expensive, and it is more faster, and it is again cheaper. So it provides efficiency. And the last but not the least is the trust. So by creating a secure and transparent system, blockchain technology can help build the trust among the parties who are involved in the transaction. So thereby reducing the need for the intermediaries and increasing the efficiency of the transactions of blockchain. So these are the objectives of blockchain technologies, that is to have a decentralized network, decentralized digital database, to have the transparency in the transactions, to provide security, to enhance efficiency, and to build the trust. So these are the 5 objectives of blockchain technology. I hope that you have understood each one of these objectives in a very clearly manner. Now, let's understand what are the challenges of blockchain. So there are 6 challenges. The first challenge is the scalability. Second one is the energy consumption. Third one is interoperability. Fourth is the regulation. Fifth is the security, and sixth is adoption. So let's understand these challenges in a detailed, in a nutshell. Just give me a moment. Yeah. So the first challenge is the scalability. Scalability means what? As and when the transactions increases, it will be difficult in handling high number of transactions. So that is a challenge. Second challenge is the energy consumption. So if I'm using the proof of work as a consensus model, then it consumes more power, because the proof of work consensus model requires a complex mathematical puzzle to be solved. And in order to solve that puzzle, we need to have high-end CPUs, high-end machines in terms of RAM, in terms of CPU. So here, this will lead again to environmental issues as well, that is carbon footprints. So that is the environmental issues. And again, it consumes energy. It requires high-end computers. Regulations, definitely. There is a legal uncertainties in many countries, in many jurisdictions. Some of the countries, they are not still accepting fully the blockchain technology. So regulations are again very important challenge, very big challenge in case of scaling, in case of enhancing the blockchain technology in various regions. Interoperability, again, is very difficult one, because nowadays there are different flavors, different versions, different platforms of blockchain technology. Every blockchain platform is different from other one. So it is very difficult to transact between different platforms, between different blockchain platforms or the networks. So there are issues of interoperability, that is difficulty in integrating with the legacy system, with the other blockchain platforms. And adoption, because of the cultural differences and because of the systematic change. So again, it creates and hurdles in adopting this technology. So this is about the challenges of blockchain, that is scalability, energy consumption, interoperability, regulation, security, and adoption. Now let's understand what do you mean by the transactions and what do you mean by the blocks. So basically, the transaction is nothing but the digital operation which is recorded on the block. So we can say that every digital operation that is recorded on the block, we can consider it as a transaction. For example, a transfer of cryptocurrency from one account to another account, that is considered as a transaction. So a transaction is a digital operation that is recorded on the blockchain. As simple as that. The second component is blocks. What is a block? A block is a group of transactions that are bundled and added to the main blockchain. So basically, what is a block? A block is nothing but a group of transactions that are bundled together and which are added to the blockchain. So that lead to creating a block. So a block is a collection of transactions bundled together. That's it. Now let's understand the structure of blockchain, or structure of block rather, how a block has been composed of. What are the different parts of a block? The first part of a block is the block header, which includes the previous hash value, which includes the hash of the previous block, the timestamp, and the knowns that comes under the block header. The second part of a block is the Merkle root. A Merkle root is nothing but the summary of all transactions. Every transaction is having a hash value. Suppose that in a block, there are 10 transactions. So there are 10 transactions means what? There are 10 hash values which pertain to each of these transactions. So now, by using the Merkle root, we are representing all those 10 transactions with their hash value into a single hash value that we call it as Merkle root, so that we can use that single hash value to represent that block and to connect that block to the next block. So that is the second component of a block. The first component is the block header, composed of this timestamp, the previous hash value, and the nodes. And the second part is the Merkle root, that is the summary of all transactions. And the third part is the actual transaction data of that block. So these are the three components that you will find in every block: block header, Merkle root, and transactional data. Now let's understand one case study of blockchain in case of supply chain management that is being used by the Walmart in the collaboration with IBM Food Trust. So here, the problem they are facing with is they are facing, that is the transparency, lack of transparency and traceability in their food supply chain. So they want to address the problem of transparency and traceability. And with the help of the IBM, Walmart has partnered with IBM. Walmart has collaborated with IBM, and they have used the blockchain for tracking the product, for creating the transparency in their food traceability with the help of blockchain. And the result, when they have used the blockchain for tracking the produce, they have found that the time to trace has been reduced. And again, the food safety is enhanced. And again, they have minimized the wastages. So definitely, blockchain enhances the transparency, traceability, and accountability, even accountability in the real world operations. So this is one case study that is very important in case of blockchain technology. Now we'll understand the last component of this unit, that is a P2P system, that we call it as a peer-to-peer. What is P2P? A P2P is a decentralized communication model where each participant, that is peer, can act as both. That is, they can act as the client or they can act as a server. So a peer can act as both, as server at time and the client at another time. So that is the concept of peer. What are the features of peer? Peer-to-peer system, that is, there is no central authorities involved. There is a direct interaction among the peers, among the nodes, and it is resilient to single point of failure. And there are different types of P2P systems. That is, all nodes are equal. That is pure P2P. For example, Gutela. And again, we also have the hybrid P2P system as well. That is the uses of the central servers for coordination. For example, the BitTorrent. As we are, I think we are familiar with the BitTorrent application. BitTorrent is a file protocol application using P2P architecture. So here, in case of BitTorrent, the files are split into chunks and they are downloaded from multiple peers simultaneously. And if it provides efficient, scalable, but sometimes it can associated with piracy. So P2P in blockchain, that is every node in a blockchain network is a peer. Nodes can share and validate the data equally and helps achieve decentralization and consensus. So to sum up this session, I would like to say that blockchain is revolutionizing the digital interactions through decentralization, transparency, and security. And understanding its core principles, fundamentals, components, and real-world applications is essential for adopting it effectively and for adopting it in a real-world manner. So this is all from this session. I hope that today the content that I have delivered, it has been very well comprehended, very well understood by you. So if you have any queries regarding the content of this session, you can connect me through WhatsApp or through email as well. So with this, I would like to conclude this session. See you in the next session. Until then, have a great day ahead. Thank you very much for joining and watching this video later on. Thank you very much.